Okay, hello and welcome everyone to this talk from the Data-Centric AI Summit. So I'm Victor, your host, and I'll be talking today about from a simple CLI tool to a powerful platform. You'll see what I'll mean with that in just a second. The goal here is to give you an idea of what options there are. You have a simple CLI tool, you have some steps in between, and then obviously you have the powerful platforms as well. The goal here is that you will see a lot of ClearML, but the thing is that it shouldn't be ClearML specific. So you can do this kind of workflow or this kind of idea on any type of tooling that you want. It's just good practice in general. So first of all, who am I? Like I said, I'm Victor Sonk. I'm a developer advocate at ClearML. I've been working for 4 years as an ML engineer. And then I came over to ClearML to do this kind of thing, which is awesome. So I make YouTube videos, I do talks like this, blog posts as well, and love tinkering and making with machine learning. So there is a channel called ML Maker, of which we have now only one video, but more are to come, with which you can see what you can build with machine learning in a fun and cool way. So yeah, that's who I am. That's enough about that. Right. Data management, right? Today is all about data-centric AI. So what is it? Like the point is here, you have annotated data because the labeling phase is over. Is it though? Like it's going to be cyclic, but still you have annotated data in some capacity. And now what, right? A lot of people will tend to use this kind of thing. So they have like the Cocoa data set, and then they change some stuff, and they have the best Cocoa data set, and then they change some stuff again, have no cats versions of the data set, and so on and so forth. So it's not ideal, right? And there's probably other ways to go about it. And this is actually the first step, is how can we do this data management correctly, right? Before we get started into data-centric AI, we need to manage our data, basically. And that's actually what level 1 is going to do. We'll go through 3 levels in this talk. And level 1 is just basic data management, right? And what do I mean with basic data management? Basic data management, it should actually do only 2 things, in my opinion, at least. It should have versioning and lineage, which essentially means that you have a history of all of the changes that you did over time on a specific data set, right? It's a bit like Git, but there's several things that you would do with code that you wouldn't do with data. But still, the feeling is kind of the same. The idea there is that you can always go back. You can always have visibility in what data was added. It makes it easier as like a person coming into the project to see what it's all about and stuff like that. So that's like the very basic stuff you need. And then the other side is accessibility, which is a thing that a lot of people look over or like don't take into account. But the main idea there is that you're going to be training your models either in a team on many different machines, or, and most probably, on remote machines as well, which can be any machine, like a cloud machine or some on-premise hardware that you have. So it should be accessible by those machines. Those machines should be able to get a specific version and then run your AI or like train your AI using that specific data, right? So that's the accessibility part. Right. Let me just show you what that looks like if you were to use a data management tool like ClearML, right? So we have here a food data set that I specifically tailored for you today. And the main idea is here you have the lineage, right? So you have previous versions over time. Those depend on nothing, right? And then you have these that depend on the previous version, right? You should be able to see all of the contents here. So I added some pizza, I added some waffles. If I go to the preview, let me just show you, you have like interesting statistics. And this is actually one first thing that is different from just cloning folders with data, is if you have a good data management tool, make sure that you also include plots, also include descriptive statistics, because you can do that, right? And these statistics actually do belong to the specific dataset version they're attached to. So data is not just the content of the data set, it also is all the metadata around it and plots that visualize that metadata, basically. Right, so these you can auto-generate and add to the ClearML data in any capacity. And then you have, obviously, ways to also visualize different contents of the data sets. So the content is just a list. And then it becomes interesting when you have multiple versions, right? Because data is usually going to be a lot of data, right? Huge, big data sets, and you actually want to keep that relatively well managed. So a way to do that is, if you can see, I added croissants here, but also still the pizzas and the waffles are still in there, right? So the only thing that I added are croissants. But if you go into the preview, what you'll see is that not only do we now have croissants in the plot here, but also we have only images from croissants. And what it actually means, it has differentiable storage. Is in this data set, in this version of the data set, the only data that is stored is the data that is different between the previous versions. And you can see that here as well. We added 18 croissants, but nothing else was stored, right? And this way you have like differentiable storage, which is the very, very basic approach of doing this. And then the last thing that I want to show you is you also have ways to externalize your data. So in this case, these type of tools, including ClearML data, will actually take care of these images. This is a data set that we made with our good friends at Toloka, which also have a talk. You should definitely check those out. And you can just save all of these JPEGs, all of these links to an external database or an external object storage. So that's the very basic idea of basic data management. So what are the basics for ClearML specifically? You can create a data set. It must be very, very simple to do, which it is. You can see it here. ClearML data create, give it a project, give it a name. That's it. You just add some files and close it. Super easy. You can do it with the CLI like it's in this slide, or you can do it directly from Python as well. And it should support multiple storage media. Like I said before, you can just add links to a specific S3 bucket or something similar, and that will work as well. You should be able to get it as well. Remember accessibility. So getting the data is ClearML get this from the project, get it from the name. You can also give a specific ID. This will just grab the latest. You can also search for it if you don't know the ID by heart. You have the different options there. So this essentially abstracts the storage medium. You just say, I want it from a project with a specific name. I don't care about where it is stored or what is stored. It also does smart caching. Like I said, you have the different differentiable storage, but also if you get the data, this will essentially just make sure that you never get things twice. So if you get like a new version, for example, it will not download all of the other versions that are below it. And then also searchable datasets is a useful thing to have. Right. This was the very, very basics, right? This is what we want to get started with. Now, level 2 is connecting these datasets or these dataset versions to experiments. And this is actually where we start to get into the loop of data-centric AI. We want to put data into the center of our AI iteration cycle. And we do that by connecting them to experiments. An experiment manager is actually a kind of tool that you want to use anyway if you're training AI models. And so the main idea here is that we want the dataset version ID as an experiment input. So not only are hyperparameters or just command line parameters or other kind of inputs for your experiments, the dataset version ID is one too. And you actually want that in your experiment manager so that it's trackable, but there are extra things we can do there later on. One of the things that allows you to do is allow for experiment comparison. So you can actually compare different experiments with different data or train on different data, but with all of the rest of the variables the same. And then allows you to actually check which kind of data was working, which kind of data set pre-processing or post-processing steps were working as well. So you can easily compare that using the built-in tools of any experiment manager at that point, right? So now you're talking AI specifically, but data is still at the center of it. You want to do analysis, sensitivity analysis on that. And we also want to be able to easily reproduce it with new data. And this is something that I'll show you in ClearML specifically, because ClearML has the functionality to actually take your experiment and then clone it, and then run that clone again, but with changed parameters. And something that becomes really, really cool there is that you can just change the ID of the actual data set, and then you can just retrain your model with that new data with just a single click. And that's really, really powerful by adding this link to the experiment manager. And this is basically the definition of data-centric AI, because at that point, you're just iterating over your data, and it's just 2 clicks for a new model and see how it performs. So that's really, really powerful. I'll actually show you that in right now. If we go and look at our projects here, which is specifically the experiment manager, we can see AI data-centric AI. This is, guess, this is the one that we're going into. So we have two data sets here, or two models here, sorry, two experiments. So one of which is model training old data set, one of which is model training new data set. And just like any other experiment manager, things are tracked like code and uncommitted changes, installed packages, configurations, such as like batch size, LR, momentum, stuff like that. Models are saved, console output, scalars as well. And these are the interesting ones because we'll be looking at those shortly. These are essentially the accuracy and the loss, which is what we want to minimize or optimize, depending on which of the two you're talking about. And then we also have some debug examples in which we can see, okay, how was the predicted label and what was the actual label, the ground truth label, right? So this is just like a normal experiment manager, but like I said before, you can actually select both of them and then click compare. And if we go into the hyperparameters here, you'll see that the only thing that really changed is the dataset ID. I actually forgot to show this, so let me just go back real quick. In the configuration, next to the batch size, the decay gamma, the decay step, et cetera, you also have a section datasets. And this says which dataset was used to train that specific experiment, right? This is what I was talking about before. So if we select both of them and click compare, go to hyperparameters, we see that this is the difference in datasets. You can always track those through time. And then also, if we go to the scalars, we can see the old dataset and a new dataset, how they performed. So they were the exact same model because our general settings didn't change at all. So there was the exact same model, and we see that the new training dataset is actually performing much, much better than the old one, right? So this is a very good idea of like a very good way of analyzing this kind of thing, right? Right, and then there was a last thing that I said. Also, you can compare debug examples, obviously. So that allows you to look with your own eyes and basically decide for yourself, do these scalars actually translate into real world gains here? And they do, right? So if we go back to projects and to our data-centric AI here, one more thing that I talked about before was the cloning functionality, right? So if I go into one of the data sets that I have here, or like one of the experiments that I have here, I can actually press clone. I will just call it clone of new data set for now. Obviously, you want a better name, but this will make it very clear what it is. And what you can do now is you can change a whole bunch of stuff. So for example, I could change any of the parameters here, but I can obviously also change the dataset ID. And this actually means that if we just have a new data set and we can just change the ID to the new data set, then all we have to do is just copy paste it here, click save. And if we then press on enqueue, we can enqueue it in any of the queues of the system. You can add as many queues as you want, obviously. And it will say we have no agents assigned yet, so it will not actually be executed. But if you have any remote machine that is listening to those queues, it will now pick up that package, basically that task, that experiment. It will overwrite the parameter that we just changed, and then it will run the whole process again, just from scratch. And this is very, very powerful stuff because now you have like a continuous cycle with just 2 clicks of a button, right? So this is going to stay pending. We're not going to wait for that. So I'm just going to go back to the slides here and give you some of the best practices in this case. So now you've seen what this kind of thing can do. What are the best practices that we can do, right? So I'll call this enhanced data management on top of the basic data management that we had before. And the first thing is to store the pre-processing script with the data itself. So remember that I said you can add plots, for example, like the histogram or like the class distribution to a specific dataset version. You can also just store artifacts like models, or probably more useful in this case, Python files. So this actually makes it very interesting because you're not only going to track your Python files using obviously Git and just normal code versioning, you also want to have a copy of the specific pre-processing script that is used for that specific version of the data attached to the data. Because if another department or another person is going to use that, they have that script available together with all of the data. And this is one of the major benefits of these data management tools, such as ClearML data, by the way. Store plots and metadata with the data itself, just like I said. You can store the plots, but you can also just store pandas data frames, for example. So imagine if you have like a whole bunch of images, you can just throw a pandas data frame in there with all of the labels. That is relatively basic. There are better ways to do that, and I will just we'll go into one of those shortly. But this is a good practice in general. Then, like we said, log the data version ID as an overridable experiment parameter, right? This is what I just showed you, is in your experiment manager. It doesn't really matter if you use ClearML or any other one. Just make sure that your dataset ID is always available in the experiment manager for traceability, but also for reproducibility, and then hopefully for cloning. And so one thing that I didn't show you before is you can tag a dataset. So if you go here, you can actually go to the datasets. In this case, it was food dataset, and you can actually give it a tag. So for example, I would say production, this one is ready for production, and then I can sort on that. So I can say I only want those with tag production. And you can do that in the Python SDK as well, which means that you can set up a whole bunch of processes that only react when you publish a dataset as production, for example. That makes it a lot easier for browsing, but also for automation in the long run. And talking about automation, we can create automated triggers on newly incoming dataset versions. So this depends on which platform you're using. ClearML does support this, where you can say, okay, I have a specific trigger here, which could be, for example, an incoming new version of a dataset, or I have now tagged a dataset as production, that can automatically trigger a new pipeline or a new process that can, for example, clone this experiment and run it on the new version of the data for you. So this is really, really easy to set up. And then just from creating a new dataset version, you immediately have a new model as well, which is, again, very powerful. And then we come to level 3. So level 3 is Hyperdatasets. Hyperdatasets is a specific thing that was developed specifically for ClearML, or like by ClearML. It's also in the paid version of ClearML. Everything you saw so far is open source, because ClearML is an open source MLOps platform, apart from Hyperdatasets. But you can check everything on the website if you want to. Right, so the first thing that Hyperdatasets can do for you is dataset exploration and statistics. So it's just a very nice tool to go into your data and understand it better. And that's something that the basic and the enhanced dataset versions or dataset management tools, didn't have, and that is proper exploration and statistics. It's really difficult to do that because it should be scalable. Like I said, the data will be huge and massive, and it's pretty hard to work with. So you need a tool that is specifically designed to tackle these challenges. Queryable data management. Now, here is where it becomes very interesting, because the whole idea of hyper datasets is that you disconnect the data itself from the metadata on top of it, right? And like in the examples before, if you have ClearML data, like the open source version, what you'll have is everything is connected together. Like everything should be a file. It's file based, or it could be the metadata with like a pandas data frame. But you can't really do anything with that metadata. Which means that if you, for example, have a huge data set and you want to train specifically on, let's say, traffic signs or dogs or whatever you want, you should download the whole data set and then write your own code to subset on only the things that you need, which is not ideal, right? So that's where queryable data management comes in which you can say, I want a view of the data that only includes things that follow my specific guidelines, that follow my specific queries, right? So this is what Hyperdatasets allows you to do. And what that ends up resulting in is powerful, very powerful data views. And data views essentially allow you to connect a specific view of the complete data set based on queries and parameters, and then attach that to an experiment. And now, remember the cloning, right? So now all of these data pre-processing stuff are also parameters on an experiment that you can just clone, change, and rerun. And that's where it becomes very, very powerful. So those are the data views. I'll just give you a sample of what that looks like. So this is the exploration version of the Hyperdatasets, right? These are not the data views yet. I'll show you that in a minute. But this is just the sample, right? So this, again, is the data set from our good friends at Toloka that we work together with. And we have a cool data set that is full of food, right? So you'll see here, we have like a quick statistics that is all generated on the specific labels that are in the data set. We have a way to look at our data and go through it. we actually have options here to add, for example, bounding boxes or ellipses or polygons or key points. It's like a whole annotation tool in its own as well. But you can see the labels here. So these are specifically frame labels. You can have, for example, a label here that says a peanut, but we don't want that. It's also not a peanut. And we have frame labels as well. In this case, we actually asked people to rate a specific image for appetizing or not appetizing, which is like super subjective. And we also wanted them to rate it for solid or liquid, right? Which is relatively objective, let's be honest here. And this is actually the confidence you will see, because there are multiple labelers doing the work here. You can actually take all of their votes into account and create a confidence score of whether or not this was solid or liquid, which should be a high confidence, but also subjectively appetizing or not appetizing. And this is actually really interesting, because now we can start to use our querying functionality to go in, to really dig in there, right? But before we do that, you can have like the version info right here. You have version metadata. So for each specific version, you can have different metadata. And the versioning is still there, right? So you still have labeling around 1, labeling around 2, which are like 2 different versions of a specific data set. You can show everything just as a list. The thing goes on and on, right? But if we switch to advanced filters, what we can actually start doing is the querying thing. So I can, for example, say I only want to include things that are appetizing with a confidence between 0.7 and 1. And it will filter out quite a bit of them already. And then actually we can switch that around and make it non-appetizing, between 0.7 and 1. And then we get like nuts and all dark and grayish colors, whereas appetizing is a little better. Like obviously it's very, very subjective. The labels aren't perfect, but this is much more colorful than the thing before. So apparently color has a big difference on whether or not something is appetizing. And then you also have frame rules. So what I didn't show you yet is that a specific frame can have metadata. And for example, this says, I have here num labels 37, right? So that means that 37 people went in and labeled this image, which gave me a confidence of 97% on some, right? So what I could say is I want meta.numLabels to be between, and this is Apache Lucene. This is the querying language that we're using. But I basically want all the labels that have a confidence score, that have an amount of labelers from 3 to 99. And now you only get the labels that are specific, that are labeled more than 3 times, basically, which makes it very interesting to go and say, okay, we have this very subjective labeling experience or very subjective labeling thing. Now we can subset it by just saying, I want only the ones that are appetizing between 0.7 and 1, but exclude everything that was labeled by less than 3 people. Because that's obviously a bit biased and it's not ideal. Right, so this is like the exploration tool. You can test out your different queries here, but then, and now we end up completely with data at the center of our AI workflow is the data views. So if we take those queries and we add them into the experiment manager, this is what it looks like. So this is, again, the experiment manager. We have an experiment list here. We still have our execution, our configuration, our console, our scalars, but this is like a very basic version of that. And then data views is literally in the center of our AI workflow. So what we have here is we can say, okay, we have an input of the AI demo data set that we just went through. I want only labeling around 2, and then we start filtering. So now we have a frame filter. For example, I want all versions, and I want to include the label keyword appetizing with a specific confidence score that I want, for example, to be 0.7. But I also want a ratio of 1:2, which means that I will take twice as many liquid keywords as I will take appetizing keywords, which actually allows you to change the weight of the presence of specific data in your data set. And that makes it also very interesting to do cool stuff with, because if you have underrepresented or represented classes, you can change that with this ratio. And then add a filter on top, or as many filters as you want. Then we have some other options. So we have, for example, mapping that can all be done on the fly. Remember, all parameterized and all very, very easy to clone. And then we have a mapping. We can, for example, set solid to ignore, not appetizing to ignore, and other to unknown. And then we can enumerate that label as a 0. We can change that basically all the labels to numbers, train them on, and then go back. Super easy. And then my personal favorite is augmentation out of the box, which is super cool. You can just add an affine or a pixel transform, or even a custom if you want to go that far. You can change the scale, reflect them horizontal, reflect vertical. You can say strength higher for more versions, or like for more augmentations, lower for less augmentations. So you can add these augmentations, and then you have obviously an iterator. So what in your code will be given is basically an iterator to go through the data that results from this screening process, like this data view. And then these are the controls for that. So you have some random seeds there as well. And then the last thing, obviously you can clone it, and then you can change those data views all again, change them up, change the parameters, change the configuration, and then enqueue it right back again. So I hope you can see how powerful this can be. Right, so thanks for bearing with me. I'm just going to quickly recap. So what are our options today? We had basic data management, which was lineage, or like the version history, and accessibility. Those were the most important things. Just do that. Like with any tool, this is just very, very good practice. No one should not be doing that. Then hopefully you are able to then use this tool, which will give you dataset version ID, and then connect them to your experiments. And then add some best practices such as automated triggers, or like adding plots to your dataset versions or stuff like that, which will make you even a bigger brain. And then hopefully you also see the power of queryable and parameterized dataset views with Hyperdatasets. So this finally finishes the meme, and this is actually the last slide as well. So thank you so much for bearing with me. If you have any questions, put them in chat. I will be there looking at them. If you want to check us out as clear.ml, app.clear.ml if you want to go straight to the console. ClearML is completely open source, like not completely, I'm countering myself. It is mostly open source. We have some premium tiers, one of which includes Hyperdatasets. But everything open source you can check out at github.com/allegroai/ClearML right here. We also have a Slack channel. Most of our questions come from there. If you have any issue trying stuff out, go there, ask a question. You will probably get an answer within minutes. We are like continuously monitoring that. There's some good people on there. So yeah, join the community. Why not, right? We have a Twitter as well for the goodest memes at ClearML Up. Myself is at Victor Sunk. Try it yourself. It's open source. There's no reason not to. So thank you very, very much for listening. And yeah, feel free to post questions in chat, and see you next time.